Hi, my name is Casey Ellis, and today I'm going to talk to you about volcanism on Mars. Sure, the first thing that comes to mind when we think of Mars is crazy-looking green Martians. Obviously, this isn't the case. Mars is a complex planet, though, and we still have much to learn about it. Its volcanism in particular remains a hot topic in research today. Before I go into volcanoes, I'm going to give a few facts about the red planet. Mars is the fourth planet from the Sun, and its year is 687 days long. It is half of the size of the Earth. It has two moons, Phobos and Deimos, and an atmosphere of mostly carbon dioxide. Now, on to volcanoes. On Earth, volcanism is mostly tied to plate tectonics, which is how the planet loses its internal heat. There are three main volcanic mechanisms: mid-ocean ridge basalts, volcanic arcs like the Ring of Fire in the Pacific, and magma plumes, or hotspots. On Mars, though, we only have surface evidence for hotspot magmatism because basalt is the primary rock type. Furthermore, Mars lacks plate tectonics. This means that plumes are allowed to build and build, becoming bigger and bigger. Because of this, and less gravity, Martian volcanoes are much larger than the ones here on Earth. This brings us to the Tharsis region, the largest volcanic region in the solar system. Commonly called the Tharsis Bulge, it stretches 5,000 kilometers across and is 7 kilometers high, excluding its volcanoes. It dominates the western hemisphere of Mars. This is an image based on MOLA data. The Tharsis Bulge is a large area at the left, shown in shades of red and white. According to the standard view, Tharsis overlies a hotspot, as mentioned earlier, similar to the one thought to underlie Hawaii. Geologic evidence, such as the direction of ancient valley networks around Tharsis, indicate that the bulge was largely in place about 3.7 billion years ago. Some recent research on Tharsis is being done. Geologists Andrea Borgia and John Murray published a paper in 2010 with a thesis that Tharsis region may be a single giant volcano. They compare it to Mount Etna in Sicily, a complex spreading volcano that is characterized by three main structural features: a volcanic rift system, a peripheral compression belt, and a system of transitional faults. This remains a controversial issue, though. Finally, I'm going to talk about the big one, Olympus Mons. It rises 18 kilometers above the surrounding plains. Mauna Loa of Hawaii only rises 8.8 kilometers above the seafloor. It is also about 600 kilometers in diameter, or about the size of Ohio. Though it is not technically a part of Tharsis, it is often associated with it because of its close proximity. Again, Olympus Mons is the result of a single large hotspot, but it is not active today. That's all for now. Thank you for listening, and I hope you enjoyed learning about Martian volcanism.